Today, I'm going to show you how to use Retrieval Augmented Generation, or RAG, to run a large language model on your laptop using open source tools. And let's get started. So, why would you do this? There's a few reasons, really. Firstly, you may have sensitive data that you don't want to send out over the internet. You may also work for a company where you have restrictions inside where you can't use these sorts of services and tools. Also, you may just want to actually have more flexibility in the apps that you're building. So with all these in mind, like what are these tools? What are we using here? So to start off, there's two open source tools that I like to talk about here. The first one is Langchain. The Langchain is basically just a framework for working with LLM apps. And what it allows you to do is get started faster, less code that you have to write, less boilerplate code that you have to write, and allows you to get your idea out there a lot quicker. And the second tool is Ollama. If you're working with open source models, there's a couple of tools around there, but Ollama is a very flexible, very easy tool to use where you can actually go and just download these open source models and have them run directly on your hardware there and then. It integrates very well with applications as well, so that's why I like to. And then getting into the main topic here, which is RAG. So why would we use RAG? Why not just use the models that come straight out of OpenAI? There's two main reasons here, and they both center around training. When you look at training a model, if we look at the models that open source or that OpenAI, for example, are training, they're quite expensive. Like they're running into the billions of dollars now of compute required to train them. And obviously we don't want to have to go through that cost or that effort ourselves. So we want to ensure that we're leveraging these models as a base. So they're trained up to a certain point. And you'll see this when you're looking at the likes of OpenAI, where it's got a cutoff date. So it only has knowledge up until X date. So we want to leverage that. We want to start from there, but we want to then add our own data on top. And that's where the other component comes in, where these systems are trained primarily on public data. They're not trained on your internal private data, or at least they shouldn't be. And so for that reason, we want to add more data to it so that it gives tailored answers to the specific needs that we need. So I'm going to give a quick look at an overview here of how a RAG application works, and then we can get started into the code. So this is an overview of how a RAG application works. In our typical use cases, if you're using ChatGPT, you are the user, you ask a question, go straight to the LLM, and you get an answer. And this is all based on pre-trained data and what the LLM currently. What we want to do is add in this additional piece here. And what this is going to do is this is going to add specific context to the LLM so that you can work with your data directly. So what we do here in this case, the document represents the data that you want to pass in that's yours. What we do is we break it up into chunks. And the reason for that is all language models have what's called a context. And it's basically just saying that this is how much information you can pass through it in a single session. And to ensure that we're getting the maximum effect out of that, we want to break our data up into chunks. And what we do with those chunks then is we convert them into their numerical representation. That's just a really fancy way of saying we convert the text into numbers so that the computer and the large language model can understand it better. And we store that data into a special kind of database called a vector database. So we're converting the text into vectors, which are numerical representations, and then we're storing them in a vector database. So that's the capturing your data and storing it so it can be used. The second piece is that we use what's called a context receiver, and a context retriever. And what this is going to do is this is going to take the user's input, the user's question, go to that vector database, search it based on what the user is asking, and bring back only the relevant context. So imagine you've got hundreds of documents that you are uploading, but your question only relates to 4 or 5 of them. You're going to only grab the pieces from those documents that are relevant so that we don't overload the context. And then once we actually retrieve that information, we're going to merge it with the user's question, pass it to our model, and then the model will answer in a normal fashion. But what it's doing is it's answering with both the user question and the relevant context at the same time. And this then allows us to use the base model, integrate our own data, and get a response and chat with our documents. Okay, so now we know the problem space. Now we know what the tools are. Now we know why we would do this in the first place and how it works. We're going to step through a bit of code here. Now, what I'm going to do is I've already written this code, so I'm actually just going to step through it and point to all the pieces. I'm going to link the repo down in the description so you can actually go grab this code, run it on your own machine, and you can test it out yourself. But there's 5 key steps that we're going to walk through. So the first one is we're going to load up our dependencies, going to get our project set up. The second is that we're going to then initialize our UI. So we need some way of interacting with the model. And for that, we're going to use an application or a framework called Streamlit. Really, really simple, couple of lines of code, and you've got a UI up and running. After that, we're going to initialize our vector database, which in this case, we're going to use a service or a tool called ChromaDB. Open source, very lightweight, very easy to use. And then we're going to create our retriever chain with Langchain. And finally, we're going to bring it all together by creating a chat interface, again with Streamlit, hooking it up to our retriever chain so that we can actually go and talk back and forward with the doc that we have. Okay, so if you've gone to GitHub and you follow the link below, follow the instructions, you should now have the code on your machine. I like to use Visual Studio Code, but you can use whatever you prefer. I've kept this example really simple, really light. Everything is contained within one script file. So go into the application, not your app.py. And what we're going to do is we're going to jump first to the first section, which is initializing the UI. So as I mentioned earlier, we're using a framework called Streamlit. It actually is built for data science projects. And it's a very, very simple way using Python to set up a UI on top of your projects. So we're just doing some basic stuff here. We're setting up the application. We're initializing the session. And what this is going to do is this is going to hold on to our chat history. So as we're chatting with the bot, it retains it, and then we can replay it. And also we're storing the vector store, which is we only want to initialize the database once and pull it back every time. And then the main part here for this, the initial piece, is that we are going to create a file uploader that's going to upload a PDF file, and we're going to save that file into our data directory here so that we can pass it through to our LLM. The second part, as we said in our earlier overview, we're going to initialize our vector store. Again, we're using ChromaDB. We're using the file that we uploaded in the first part. And what we're going to do is follow that path that we showed earlier, where we're going to break it up into separate pieces, and we're going to store it into the database. So to do that, we first go and load our file. So we're going to just for convenience sake grab the first file that's in the directory here. Then we're going to split it up using a recursive text splitter. This is actually one option. There's other options and more advanced options that are coming out these days, but we're going to keep it really simple for this example. And then finally, from those documents, from those pieces that we've chopped up, we're going to initialize our database. And it's very simply here, we're just actually telling ChromaDB to take our document pieces, which we have here, and initialize the database. Now, one interesting thing to look at here is we're using the Ollama embeddings. Now, the reason we're doing that is because we're using Ollama to serve our local LLM. If you're using something like OpenAI, you pass in the OpenAI embeddings here, and likewise for any other platform that you're using this for. But for our sake, we're going to use Ollama here. And then the third part that we said is we're going to actually have a retriever chain. Now for this, we're using Langchain. And from the very top, Langchain is a framework for working with LLM apps. And in this case here, we can see we have an interface for working with Ollama, and we just tell it the model that we want. So now we have our LLM set up. We're going to create a retriever chain from our vector store. And the first part of this is that we are going to set up our chat prompt to go and query our vector store and retrieve similar information to our query. So this is the retrieval part of our RAG application. The second part then is using the context that we retrieve from the database, we're going to query our large language model with the user's question plus the context that we retrieved. And what this allows us to do then is add our own information to the query query the database and then query the LLM, and we get a response back, and we can chat back and forward with the LLM in this same app. And we can see here again, we set up our LLM, we set up our prompt, and what we're doing is setting the context, passing in any of the chat history, which we have saved to the session state, and then we pass in the actual user's question. From this, then, what we do is we create two chains. One is the chain that we're going to use to query the LLM. The second is that we're using a retrieval chain, which is what we created earlier in the previous step to go and fetch our specific data from the vector database. And the last step we have is to bring it all together. So skip down here first. First, what we're doing is we're going to initialize our chat interface. With Streamlit, it's really, really simple. All you have to do is actually use this chat input feature, and it'll set up a functioning chat interface. No need to go writing JavaScript code or front end stuff. Couldn't be easier. And what we're going to do is we're going to use the history that we've been maintaining around the chat to build up that chat interface. So if you think about something like ChatGPT, it's the exact same thing. For your request, every time you write a message, there's going to be a response, and so on and so forth. And then what we do within all this is every single time the user asks a question, we're going to fetch the response from the LLM, but we're going to do so using the two chains that we created earlier. So we've got our context chain, which is going to fetch the data from the vector database and return it. And then we have our RAG chain, which is going to merge that with our user query, send that to the LLM, and we get back our answer. And you can see here, we invoke the full chain. So we're saying, take all these pieces, run them as a single unit, and then we actually get back our answer from the result. And there you have it. So just to recap what we've done, we've gone through why you would actually want to build a RAG application and how it helps with some of the training issues with large language models. We've looked at Langchain and Ollama as two very good open source tools for running this on your own local hardware. And we've looked at some code which actually can get you up and running very quickly from zero and have you actually interacting with your own LLM and using your own data on your own hardware. So I hope you enjoyed this video. If you have, please make sure to hit that like and subscribe button down below. I'll see you the next time.